All right, apparently this slide is where we left off. And as mentioned, you don't have to specify the type of your variable. You can use the word auto. That is a recent change, actually. The C++ language has been around since like 1980 or whatever, and this was not introduced until 2011. So 30 years, 31 years after the language was created. And just because there is a version of C standards that was published in 2011 doesn't mean that every C compiler out in the universe was immediately updated to use that version. And I've had people come in who weren't using Microsoft C, and they were using other versions of C that were not adhering completely to the standard. Just saying that that is something that you have to keep track of, not specifically over the auto keyword, but in general. If you look up something and you see that it came from a relatively recent version of the standard, there's a newer version of the standard still that introduces things like garbage collection that Java has had for a long, long time. You know, they got to compete with each other, right? So if you get on a compiler that does not support those things, then you're going to have to do it a different way. And you'll know right away, right? You try to compile the code, you'll get a syntax error, right? It's just kind of a drag. The book mentions another point. When you want to get a line of data rather than just a single word, like if we wanted to type Rose State College, when it asks for the university, I'm blipping out there. That's not something that differs on a year-by-year basis. But you have to use a different input function. You can't use CIN arrow arrow to read in multiple words, because CIN arrow arrow does what's known as tokenization. It pulls in one fragment at a time, and those fragments are separated by spaces or tabs or by returns. Just to get things rolling, we're going to demonstrate something about that. Okay, since I promised that I was going to give everybody hundreds on their homework, if you were one of the ones who got knocked off because you didn't turn in any source code or screenshots, I would eventually go back and give you full credit for it, right? But I really want you to find the source code. But you know, if your laptop caught on fire, you know, then I'm not going to make you redo the assignment. But assuming you still have access to the CPP file, go and get that and upload it. I know it's easy to make the mistake, especially if you do not have extensions enabled on your computer. File extensions visible. And I'll show you what I mean. Say I'm looking at, why does it keep resetting back to this view? Okay, say I'm looking for the file to upload. Oh, well, they're not there. Visual Studio 2017, okay. You're done with your code and you're going to upload something. Now, I haven't even been checking to see if people have been uploading SLN files into the daily drop boxes. Maybe you have been, and I should be scolding you, but on the other hand, I told you that the only thing you need to do is upload proof that you're here, and that SLN is adequate proof of that. Where's the back arrow? There it is. Okay, so you're ready to upload your homework. You find your folder and you see this file. All right, I upload that. Well, you see it's called .sln, so that's a good clue not to upload that one. But I didn't see .sln. That's very plausible, because if you do options, and view is set up to hide extensions for known file types, which is a default on a lot of installs of Windows, then it didn't disappear. How do you refresh? F5, F3, F4.
Just hit enter. I never refresh on the File Explorer. Well, then it's not changed.
So when we submit our homework, we're not supposed to be submitting just the SLN file?
No, I don't even want the SLN file.
Oh, Christ.
You can give me the SLN file, but only if you give me the entire project. Anyways, that setting that said hide known file extension types, apparently I did not actually get it changed. I did not save it. It's showing it anyways, but if it didn't, right? If it looked like that, and the CPP file also looked like that, I can see you making a mistake. If you look over here and it says Visual Studio Solution, though, you're not supposed to upload that. Go in to the source code directory, which will have the same name as the project, and find the CPP file, and it'll say C++ source. That's the one you want to give me. A way to make absolutely sure you get everything is to zip the entire folder. If you're feeling like doing that, and you're using Windows, also works on Macs, but you know, different directory structure. Right click on it and do send to. You gotta be kidding me. Where's my send to option? There it is. Send to compressed folder. And that will make a file called b.zip. Notice it is hiding that extension. It is a zip file, but it just says b. Now I utterly despise the fact that they're hiding the file extension from us, so I'm going to go back and undo that change that I made. And I strongly recommend that if you're a programmer or just like knowing more about your files, that you do that. That you go to View, Options, change folder and search options. Depending upon whether you're in Windows 10 or not, that option is under a different menu. But eventually you can find folder options, go to View, and do unclick Hide Extensions for known file types. Oh, all folders. I must not have clicked that do this to all folders thing. But no, I'm still confused as to why it didn't work on that other folder, but it is on this one. Okay, does that make sense? Feel like giving me the whole folder? That's cool. If you just want to give me the individual file, that's cool. As soon as I see you do that, you're going to get 100 on it. Also, screenshots, please, from now on.
Is that something you went over on day one?
Probably. And yeah, you enrolled and came in on the next time, so yeah.
So I've just been giving you SLN files, so now I got.
I understand. Yeah, I understand. Yeah. Ain't angry, just get it fixed and we're all good, right? Yep, ain't even mad. So file new project. You know, it's a reasonable thing to want to upload, right? It's called a solution file. So apparently this is Lecture G. Grab me boilerplate. Can't find my Solution Explorer, so View Solution Explorer, right-click Source Files, Add New Item, C++ class. I'm going to also call that, no, C++ file. I'm actually going to call that Lecture G. You can leave it source.cpp, but then you're eventually going to wind up with 20 files called source.cpp, and paste. Okay, back to the idea of tokenizing input. If you need to get multiple words out of, to store in a string because you want to ask them for their first and their last name and not make them type it into two separate fields. I may not even show you how to do that. I probably am, but I'm going to show you how CIN is working. Just do this, int x, comma y, comma z. and then do cout arrow enter x colon space end quote, and then cin arrow x. And then copy and paste that 2 more times and change the x's to y's and change the x's to z's. And then we could write them back out, right? Cout x arrow space quote space quote semicolon, and then copy and paste that one 2 more times to write out y and z. All right, if you're typing this in, pause for a moment so I can show you the side effect that I want to pause. Not that I want to pause, that I want to show. Then I'll get back to it. Probably still need to make it larger. Anyways, so it says enter x. I could type in a number, right? Great. Enter y. What if I'm goofing off, right? I'm hitting tab and enter, and it's not doing anything. Eventually I wise up and I give it a second number. And then enter z. All right. It was tokenizing the input, which means scanning and scanning and scanning until it finds a chunk of data. And that chunk of data is data that is offset, that is separated by either white space, which is tabs and spaces, or the enter key. And it kept waiting until it got some good data. A side effect of that is, watch this, and this is a little bit weird. Enter x. 1, tab, tab, 2, space, 3. And then check out what it did. It said enter y, but there was already a piece of data waiting for it in what's known as the input buffer. And so it didn't even wait for me to hit enter and type it. It sucked it out of there. And then it said enter z, but again, there was another piece of data waiting in the input buffer. And so rather than make me type anything and hit enter, it just sucked it in. And so then it printed out 1, 2, and 3 there. Hope that kind of makes sense. It's called tokenizing the input, which is what it does. The problem is if I do this, let's add some strings. String fn comma ln for first name, last name. And then cout arrow first name question mark semicolon, and then cin arrow fn. It's bad form to put them on one line, but I'll live with it for now. And then copy and paste that and change those fn's to ln's. Barbara, I bet you hate it when I go back and insert stuff earlier in the code.
Yeah.
Barbara takes notes, electronically on the iPad with a drawing program.
Which is real cool, but then I start
Trying to make your life as hard as possible. Okay, so here we go. Enter your first name. Well, what if I'm strange and I have 2 first names? John Paul. And then last name. Well, okay, it didn't give me a chance to enter a last name.
this piece of input was waiting out there, got sucked in, and so if I print out first name, it's going to print out first name is equal to John, last name is equal to Paul. Now in that case it was okay, right? But
What if I goofed on the second one and entered two pieces of name, right? Like Olivia Newton-John. She kind of has two last names, but they're separated by a dash. So my first name is Olivia. My last name is Newton space John. And then it goes kablooey.
what was happening is that this last piece of data, that John, since I put a space there rather than a hyphen, was sitting there waiting in the input. And so when it said enter X, it tried to store the word John into X, which is supposed to be a number. And then from there it went cuckoo. And that's right.
We didn't like that at all. It did not like that at all. So there's a way to fix that. There's a way to get input of an entire line of data rather than just one chunk, and it's called getLine. Let's see if I remember the syntax. So I'm going to come down to the bottom and see if I remember the syntax. CIN dot getLine parentheses FN. But we better tell them what we want, right? So above that, it's displaying an error there. Is it getLine.cin? I should Google this rather than flounder. Okay, fine. I'll Google. If it's a class reference, yes. But if it's an object reference, you use a dot or a hyphen greater than less than. I mean, hyphen greater than. Okay, it's getLine, CIN, comma, name. Come back. So, getLine, CIN, comma, FN. Please tell me you're going to work. There, yay. And then getLine, CIN, comma, LN. But we better tell the user what they need to be typing. So cout. How about just enter your full name and let's only read it into one variable. Sorry to change gears on you, but typically this is what you do. So enter your full name. We need a string to read it into. So string full name. Looks like FN could have served for full name, right? And there we go. And now let's print out that name to make sure it worked. So cout arrow arrow quote hello comma space end quote arrow arrow full name arrow arrow ENDL. And at a certain point I should have been putting ENDLs up here, right? Because our output's going to look pretty lousy without them. I better have an ENDL on this line as well. Or at the very least have one there in front of that cout. I think I'm going to do a cout arrow arrow ENDL right here above enter your full name so that that enter your full name does not appear after three numbers on the same line. Very good comment about the colon colon, by the way. All right. So my first name, I'm going to enter correct data rather than intentionally crash it. Joe, my last name is Bob, enter X, 1, Y is 2, Z is 3. And now I wanted my full name. and it didn't work. We're going to skip this part for now. That should have worked. For some reason, an inner key was waiting, and it filled in the name. It was left waiting in the input buffer. We could fix that, but I'm not going to go to this much trouble to fix it when there is a PowerPoint slide all about it. I was just introducing it to you early. Joe Bob, 1, 2, 3, enter your full name. Okay, it's just not working. Fine, be that way. All right. Professor failure. Fire me, get a new one. We'll figure out what's wrong with it when we get to the correct page on the correct PowerPoint about it. At least you see the problem. At this point in time, do not try to use CIN to read in a string that's going to contain more than one word. And so in my example where I said enter college, or if I entered a city name, Midwest Space City would be a bad name. Or enter a state name, New Jersey would be a bad name. Anybody need this on screen any longer, or anybody have typos that they'd like help with? Oh, you did not change chairs again. Every single, you're trying to confuse me so much. Alrighty. Scope. It's a mouthwash. It's a part of a rifle. It's also the scope of a variable, the part of the program in which the variable can be accessed. Well, what does that mean? If we're sitting here in our code and we declare a variable in one place, say I add a function. Not that we've talked a lot about functions, but a lot of y'all have taken other programming classes. I'm going to write a function called whatever. And it's going to print out something. It's going to print out full name. It can't do that. Why? Because full name is defined inside this function. It's defined in the main function. And they don't share data. Just because this one is declared above this one, it's completely separate. These curly braces are like boxes, right? This variable is inside one box. And now we're inside another box, so we can't see it. That's called a scope. I wonder why. Rifle, we're going to shoot the variable, but it doesn't exist because it's not in scope. Not sure. That's called the scope of the variable, also called the lifetime of the variable. The lifetime of the variable is from where it is defined until the closing brace in which it was defined. So this variable only exists from here to here. If I try to print out full name above where it's declared, that's not part of its lifetime, right? Hadn't been defined yet. Can't use it. So it's only between here and here that we can actually manipulate full name. That does not mean we cannot pass it into another function. If we pass it into another function, it would work great, right? If I do this, string full name, well, now it's not the same variable anymore at all. Now, this would not work if I put a call to it. But we're not talking about functions that much yet, so I'm not going to fix it yet. But in effect, if I called, and if I configured it correctly, and I'm going to delete this call, and I'm going to comment this line out because it's not configured correctly yet. Whatever, parentheses, full name. Now it would be able to do it. Now it would compile and work. Because we are taking this data while we're in this box, and then when we call this function, we're passing the data to it. Like a mailbox, we're sliding a letter into it. What if you don't want to go to that trouble? I'm going to tell you something that you shouldn't do. You can use global variables to fix that. I'm going to undo, Barbara hates me again, this change. I'm going to not pass it in as a reference, and instead I'm going to define full name as a global variable, which means to define it outside of any function. So I'm going to cut string full name, and I'm going to scroll up, and I'm going to put it above main underneath the using statement. While I'm at it, why don't I move this up there as well? It's good enough where it is. We're not going to actually make it work. Okay, so I cut that string full name, I scroll up, I put it above main, and now it is available. That variable is available for every function inside this file. And I could add a little caveat to that. I'll kind of mumble it. Every function in this file declared in this namespace. All right, now kind of throw that out of your brain and we'll hit it again. A file can have more than one namespace. It's kind of like breaking the file into two separate files. So that is the idea of scope. When I said that a variable's lifetime was from where it was first designed, where it was first declared to the closing brace, there is no closing brace for him, right? We're outside of any braces at all. So his lifetime is for the entire file. And as a matter of fact, his lifetime is for any file in the project. Just a sec. You can access this global variable from any file in the project, any file in the program. Won't tell you how now, but it is. The only way you could accomplish that in Java, by the way, is if you made it a static member of a class. Static members of classes are essentially global variables, but they're attached to a class. Same is true of C++. You can write classes and do that. But here, it's a variable that is not part of any class whatsoever. Yes, sir?
Is there like a global keyword to create global variables within a function?
In Python, you use a global keyword
Is there a
to
symbol?
access a global variable. In this program, there's not a keyword that creates a global variable, but there's a keyword that makes a variable's lifespan. Good question. Let's go ahead and demonstrate that. And the answer is a static keyword. Okay. So I'm going to write just a silly little function called add, something like that. Adder. Doesn't take any data. It's got a variable, int x is equal to 0. It adds 1 to x, x plus plus, and then it writes it out. Cout arrow arrow x arrow arrow endl. We're talking a lot about functions to be. Well, I guess that's what we hit, right? Hopefully. No, we were on scope. But I don't mind giving y'all extra information so that the next time you see it on a slide, it makes perfect sense. All right, so down in here in main, I'm going to call adder, right? I'm going to call it a few times. Adder, adder, adder. Is it going to print out 1, 2, and 3, or 1, 2, and 3, or is it going to print out 1, 1, 1? It's going to print out 1, 1, 1 because this variable is created and destroyed every time this function is called. Right? We call adder, it pops up here into this function. It creates a variable, it adds 1 to it, it prints it out, it closes it, the variable goes away at the end of the curly brace. Let's prove that to ourselves. Let's prove that it doesn't work. All right, what did I do wrong? Whatever must return a value. Okay, fine. Return 0. Sorry about that, guys. Scroll down, modify or get whatever function to make it return something, or change that into a void, which means don't return anything.
Return means to go to the beginning of the function, in this case, or the beginning of the program.
Okay, please to repeat.
What has to return a value?
Every function has to return a value unless it is defined as void. This function was defined to return something. We're sure talking about functions a lot. I goofed by going into this swamp. This function should have been declared as void if I did not want to add a return statement to it. Does that make sense? I'm not seeing you nod, Simon. You're not liking it yet.
No, I understand.
Oh, you're good? Okay, then am I answering the question adequately, though?
It's more like what does,
You were asking.
like what kind of variable, okay, follow-up question.
Sorry.
What kind of variable does return recall
Okay.
in this case?
You're in the same line, and that's why I called on Simon for your question. I'm sorry about that. Okay. The return statement returns whatever this is defined as. If this was defined as a string, You don't have to do this, guys who are writing these notes down. But if you wanted to return a string, you'd have to return a string. This is different from Python, where you could return any kind of data you wanted to because you didn't even give a type definition when you created your function, right? You just did def, followed by a function name, and then you could choose to put a return in there or not. In this language, if you're not going to put a return, you have to put the word void there. And if you are going to put a return, you have to put the word that matches the data type that you're returning. Back up to here, back to our adder call. It's going to print out 111. I wish this was larger still. All right. But I don't want it to lose its value every time. Okay, easy fix. Make it a global variable. Global variables are considered bad and uncool and unkempt. They make for confusing code. They expose variables to being changed when you may not want them to be changed. If you let somebody else edit your program and they start accidentally reusing variable names that you've used, and then they figure out that that variable is there, they may be changing the value of x and you're not expecting it to be changed. You may think that only your code is managing that variable. Anyways, I'm going to run it again, and now that it's a global variable, it works. 1, 2, 3, because that variable is not destroyed every time adder is called. It's not recreated and destroyed. But like I said, global variables are in bad taste. And the question was, can I create a global variable from inside a function? You can come back and put it back down here, and you can declare it as static. This keyword I do not believe exists in this context in Java, by the way. When Java was stealing lots of stuff from C++, and when I say stealing, that's meant humorously, not as a, it's good to make things look like other things, right? Apple doesn't want people to make other people's phones to look like their phones, but in terms of creating knowledge and programs and stuff like that, if you can stand on the shoulders of giants and you can take somebody's syntax and you can make it better, that's all for the good. What this does is it changes x into a global variable that is only accessible within that function. That sounds stupid. Why is it a global variable if it's only accessible within that function? But that achieves a very specific goal of making it so it doesn't lose its value. That's what the static keyword does. So when I run it, now it still says 1, 2, 3. Because I declared it as static, it exists outside of the function. But it's only accessible within the function. But since it's declared effectively outside the function, its value doesn't get lost at the when it hits the closing brace as it would be otherwise. Otherwise, there's no way of creating a global variable from inside the function. That makes sense? Unlike Python, where I think you can use the word global and instantaneously create a variable that's available to everything inside the code.
Now, what would be like the point of that though? Like, why would you? Is that just if you were planning on calling that variable from another function?
Well, what if I needed a counter for some reason? And I wanted a lot of code to be able to figure out that counter. Then yeah, I could make that counter a global variable, right? Or I could hide it inside a function. Because if I made it a global variable, anything could reset the counter. But by doing this, nothing can reset the counter. Only that function. Maybe that's a simple example, but it's honestly the only one I can come up with at this point. Yeah, yeah. You do this, you use a static when you have data that you want to be preserved between function calls for whatever purpose that you don't want anything else to be able to modify. So the scope of a variable is the part in which of the program in which the variable can be accessed. Did I tab away from this too soon, guys? Or are we good? By the way, anybody got compilation errors, typos that you want me to come look at? Please, yeah, always give me a look at it earlier. Just need parentheses after whatever. Open or close parentheses. Also it open. Whoops.
like into main.
Oh. I
Yep,
understand.
yep, just like
Okay.
that.
And expected things like, oh, that would just be.
City code.
Okay.
Yeah.
Thank you, sir.
Anybody else? Let's see what you're doing. You're trying to go to the back of the room and then you're gonna slip out the door. I like cheating. I'm sorry. She's something.
All right, now I've written a program that every time we test it, we have to enter 7 pieces of data, right? That's aggravating.
Really?
So as we add more code to it, I'll probably add it to the top of main rather than the bottom, so that we don't have to enter X, Y, Z, full name, first name, last name, every single time we want to test something new. All right, so a variable cannot be used before it is defined because its lifetime is from where it is defined to the end of the curly brace in which it is defined. But you see where it says X plus plus here? If I do this, if X equals 10, let's just make it 3. Then,
Is not equal, right? Or no?
yeah, exclamation point would be not equal. You're right. So if X is equal to 3, then reset X equal back to 0. But I'm going to go ahead and put those curly braces back in. Sorry, I made a rash decision to remove them.
What's the equals again?
Double equals does a comparison. Right. So if this code is true, it'll slip in here and reset the value of that variable back to 0. Otherwise, it's not going to. Just for funsies, call adder like 9 times, something like that. So it's printing out 1, 2, 3, 1, 2, 3, 1, 2, 3. Why? Because every time it hits 3, it resets it back to 1. Because this if statement says if this condition is true, then go ahead and reset your value. Now that's not actually the big point of this, although I want y'all to get real familiar with seeing if statements and double equals. Double equals is a comparison. A single equal is an assignment. But what's important is that we were able to use X even though it wasn't defined within this box, right? Because you can use any variable that was defined above you. This variable is defined here. It's still good to go inside the curly braces. But if I defined another variable in here, int y is equal to 1, when I tried to do something with it out here, that would be a syntax error because it's outside of this box. So this box is inside this box, and so anything that's in this box that was declared above it, I can't believe my voice went all of a sudden, it can use. It's still in scope. But this one falls out of scope as soon as we see the curly brace there. See the end of its box. So I'm just going to comment that one out. All right. So elementary case, but see out arrow value and an int value equals 100. Return 0. Maybe that looks obvious. Well, we can't print it out before we have a value for it. Here's when it's not quite so obvious. I'm going to go and create another dummy method way down here at the bottom rather than keep pushing stuff up at the top. I'm not going to even do anything. Void sample parentheses in parentheses curly brace in curly brace. Sometimes I have seen students do this, and it's not a dummy mistake at all. Right? I want you to write a program that will calculate the area of a circle. And so you do this. Alrighty, I need a radius. Int radius equals 3. Area. And then you go, okay, I know what I'm going to do. I'm going to write a formula for it because my homework assignment, what does it say? It says write a program that'll calculate the area of a circle, and oh, by the way, here's the formula. So people want to stick the formula up at the top. Int area is equal to pi r squared. So pi times radius. And then they declare int radius, and they ask the user to type radius in, right? Cout r equals question mark, and then cin arrow radius like that, and they get frustrated. They have put the formula here. Why doesn't it work? Well, because it's dependent upon variables that aren't defined yet. But I want to put my formula up at the top. Well, if you want to put your formula up at the top, you have to make it a function. You have to put it out in its own function so that these variables can be defined as parameters that were passed in. And that's way later. It's just that I've seen this, like, you know, every semester. Usually not from the people who've already taken fundamentals. But, you know, not everybody gets to this class having taken a precursor, even if a prerequisite is, you know, listed, which is okay. But that does not work, and then you get frustrated. Oh, by the way, I thought pi was going to work because we had included C math. All right, I know some of y'all have C++ experience, even though you're in this class. What did I do wrong? Why can't I get math? Why can't I get pi there? Is that it? Does C math have its own namespace?
I know it's Python, you like load the module.
Right, you have to import math, but I do have include C math up at the top, I think. Yeah, so it ought to be available to us, but maybe you have to prefix it with something. Let me look. Maybe it's like math underscore pi, something like that.
I think you had to use double parentheses for and after. Parentheses after. It's not working in my program, so that wouldn't be a solution.
C math, pi, C++. M underscore. Okay, so it's M underscore. Just like you do math.pi in some languages. But it's all lowercase, I think. Prove me wrong. I don't know why I'm taking the trouble to figure that out when I could just type in 3.14159 and be happy. But it's aggravating. Okay, it is caps. All right, my mistake. I looked at it wrong. M underscore pi. Oh, come on. Aha. That is moronic. Okay, then. To get pi, not only do you have to include CMath, but you have to put that # define on top of it. I honestly had forgotten that. I honestly don't think I ever even remembered it. Knew it in the first place. Okay. Well. Shiver me timbers and blow me down. I'm not going to take the time to fix that. I'm just going to say area is equal to 3.14159 times radius times radius.
Should that go in our boilerplate?
Yeah, let's update our boilerplate to do that. Thank you. Thank you. Brilliant. Okay, so what did it need to be? Use underscore math underscore defines. Scrolling back up above C math. Maybe above all of your includes, doesn't matter. Using underscore. My brain does not work very well. What was it?
I thought I had an underscore using. Underscore use.
Underscore use math defines all in caps. Using use underscore math underscore defines. Did I get it right this time? And that should be # define. # define. Use underscore math underscore defines. Eyeball it one more time. Yeah. Now let's just try it. I'm going to throw in a reference to math.py right here, and then I'm going to delete it. I just want to make sure it works. So m_pi. Yay. All right. Okay. That guy needs to go in our boilerplate. So if you have a boilerplate, go and modify your boilerplate to have that. And I took out that reference to pi in the adder function because it actually had absolutely nothing with what we were demonstrating at the time. I see what y'all are doing. You're trying to run out the clock so that I don't get far enough to give y'all new homework. You'd be amazed at how quickly I can generate a homework assignment. That's a rehash of an old one. Okay, I'm kidding. Well, there's a point to assigning more than one thing that covers the same topic. But arithmetic operators. Changing gears completely. Operators are the symbols of the language, not the keywords, right? We have if and while and int and, you know, all of those keywords. You also have operators, plus, minus, division, multiplication. Also, those arrows are operators. And there are other ones. We're going to see symbols for the words and or. In this language, you don't actually use the words and or like you did in Python. C++ has what are known as unary, binary, and ternary operators. I'm just going to scroll down here to the bottom and create a multi-line comment rather than go to a separate notepad file. Multi-line comment is a /*. Okay. Operators. Symbols. Defined by the language. There's approximately almost every symbol on your keyboard is an operator. There are some exceptions. I don't think there's that's a backwards apostrophe. I don't think you use one. But we're going to talk specifically about the math operators at this time. And the equal. And the equal. This is the assignment operator. It copies a value from one place to the other. This is the equality operator. Is this thing equal to the other one? You use that one inside of if statements. Then there's, of course, plus and minus, multiplication, division. Unlike Python, you don't have floor division, you don't have // and you don't have to the power of. So you can't use ** to take the power of, and you cannot use a caret to take the power of. That's why there's a math.pow function, or just a POW function. Hopefully when you include CMath, you get the power function. These are all binary operators. Not because they operate on ones and zeros. Absolutely everything on a computer operates on ones and zeros. Instead, this is a binary operator because it requires two pieces of data to work on. And pieces of data is too English-like and understandable, so we're going to give them a Latin name of operands. So, A is equal to 3. It has two operands. There's a left-hand side and a right-hand side. Cout, arrow, Bob. Arrow is an operator. I may as well tack it up here, I guess. Nah. We're still going to only talk about math, but you recognize that it's a symbol, right? X equals A plus 2. Well, that looks like it's got more than two pieces of data. It's still a binary operator, but it's two binary operators, right? This side gets evaluated. It uses that plus sign. That's the operator. And so A and 2 are the operands. Once we have a value, well, once the computer has a value for that, that is going to be the operand for the other side of the equal sign. And it's going to get copied into X. And then if parentheses X equals 5, right? Do something. Now I'm going to go back and add comments here. Although we're already in a big comment block, so maybe we don't have to do. This is going to be too much writing. I guess I'll do it down here. If you have the statement A equals 3, the operator is equal. The operands are A and 3. If you have if x equals 5, or we could even lose the word if, because that's not technically part of the equation. It's just that this gets evaluated to trigger the if. Then the operator is equal, and the operands are x and 5. And so if you have 3 plus 4, the operator is plus the operands are 3 and 4. There are 1 or 2 unary operators. Guess what unary means? If binary means 2, what does unary mean? 1. Right. So there's a unary operator, meaning it takes 1 operand. It's the minus sign. But you said the minus sign was a binary operator. Yeah, I did, but it's got a different context. If you do this, x equals -3, somehow the computer is smart enough to know that a minus sign without something in front of it behaves differently than a minus sign with something in front of it. And in this case, a minus sign with nothing in front of it takes the next value and it flips it to be negative. Now, we don't think in those terms. We see -3 and we go, oh, that's a number. That's -3. But instead, what this is 3 flipped to be negative by the minus sign. Do I care if you remember that forever? Not really. Just know that there is something called a unary operator. So if you see a quiz question over it or something like that, you know what it is. There is another one called, which is the exclamation point, and I'm not going to even talk about that yet because we're not talking about and or and not logic yet. It's a later chapter. Then is there something called a ternary operator that takes 3 operands? Yeah. Am I going to even bother lecturing about it at this point? Don't think so, because it's a special syntax for writing an if statement in a single line. And if we're not writing if statements yet, as far as the PowerPoint is concerned, why are we learning about ternary operators? But the book mentions them. Here's the unary operator, 1 minus, or a hyphen with nothing in front of it. A binary operator, there's lots of them. Most of the operators are binary, the vast majority of them. And then there's a ternary operator, which takes 3 operands. The ternary operator is a question mark. Well, how in the world does it get 3 operands? Well, because they snuck a colon in there to separate the second and the third operands. And we'll learn what this expression means later. All right, so binary operators. I think we already know what add, subtract, multiply, and divide do. And then there's good old modulus. Modulus means remainder of. If 7 divided by 3 is equal to 2 because we rounded down, then there was a remainder. What if this was 7 divided by 2? That would be 3. Why do I make careful note of that? Because you wish it was 3.5. It wasn't Python. Integer division in this language behaves differently than it does in Python. Does that mean this language is stupid? No, because a huge number of languages follow this rule, which is that if you have an int and you divide it by an int, the answer is rounded down and gives you an int. It's Python that's the special beast. You divide an int by an int, and you get a floating point number. Now I've even got Python textbooks that say that an int divided by an int is rounded down, and it's not true. Those textbooks are wrong. Maybe an earlier version of Python did that, and a later version didn't. Don't know.
So 2 goes into 7 3 times.
But it wasn't an even number, so it does have a remainder.
So 7 modulus 2. When 2 went in there 3 times, it had a 1 left over.
Sometimes people want to say, well, if 2 went into 7 3 times, then the remainder is 0.5. No, that's not really the way the remainders work, right? If we went back to grade school, we'd remember that what you do is you multiply the 3 by the 2, you get a 6, and then 7 minus 6 is 1. So, what is... I may as well tack this stuff on to our lecture notes, if you care. So, 3 divided by 3 equals 1. 4 divided by 3 equals 1. 5 divided by 3 equals 1. 6 divided by 3 equals 2. Right? What if you wanted it to behave the way that we think of? You know, where 4 divided by 3 is equal to 1.33333, repeating a whole bunch. One of these had better be a floating point number if you want that to happen, because it's doing integer division, and the reason it's doing integer division is that those are both ints. If we wanted it to do floating point division, we better do that. So I'm going to add 2 more lines. 7 divided by 3 equals 2. 7.0 divided by 3 equals 2.33333, whatever. Don't know how many decimal points it's going to contain. Probably about 16 of them. All right, that's all well and good. That being the case, 3 modulus 3 is what?
1.0. There's nothing remaining.
There's no remainder, so it's 0. Correct. 4 modulus 3 is what? 3 went into 4 one time with a remainder of?
1.
Yeah. 5 modulus 3 is what?
2.
2. 6 modulus 3 is, don't say 3. 0. Back to 0. Okay. You get it. Why do we use modulus? Because sometimes you want to, like say you know that you have ounces is equal to, 40, and you want to figure out how many pounds and ounces that is. You could do pounds is equal to ounces divided by 16, and then you have leftover ounces, right? You want to figure out that that's equal to 2 pounds 8 ounces. So you would do OZ is equal to ounces modulus 16 to pick up the rest, to get the remainder. Another example, pennies, but you want to convert that to a number of quarters and a number of cents. I'm not sure why, but you're trying to buy quarters from the from 7-Eleven, and all you have is a bunch of pennies. So pennies is equal to, and let's just pick some number, right? I have that many pennies. Then quarters is equal to that, pennies divided by 25. And once you did that, you'd get a certain number of pennies back in change, right? So cents is equal to pennies modulus 25. And if we wanted this, we could actually code this and, and compile it and make sure it ran. I think I'm just going to make a comment to the effect that at this point, pounds equals 2, OZ equals 8. Hope you believe me. And at this point, I'm going to change this number. That one's hard for me to figure out. I'm going to make that 24. All right. And as a matter of fact, I'm going to totally cheat and make it 124. There, now the math is easy for me. So how many quarters did we get when we gave them 124 pennies? We got 4 quarters. And how many cents did we have left over? We had 24 cents left over as a result of this math. So that's why you might use modulus when you're converting from one unit to the other, but you're going to have something left over. Now in our conversion homework, I think we had conversion homework, you know, convert pounds to ounces and stuff like that. We did pure division of floats or doubles, and we didn't mind a decimal point. So we didn't use modulus to do that. Did I see hands raising? Thought I saw, maybe I just heard mental hands raising. You have questions and you're shy. More likely your hand is raising because you want me to shut up and get out of here. But we got a little bit more time. A closer look at the slash operator. This is just what I've been saying. If both of the answers are, if both of the operands are ints, the result is an int. So it rounds it down. 13 divided by 5 is a 2. 91 divided by 7 is a 13. I believe it, although I can't do that in my head that fast. If either operand is a floating point, the result is floating point. 13 divided by 5.0 is 2.6. 91.0 divided by 7 is 13.0. That's one reason why when I'm calculating the sum of a series of numbers, even if the numbers are ints, I go ahead and I store them in a double. So that if I need to calculate an average later, I already have a double, I already have a floating point number. Because otherwise, you can add up a whole bunch of numbers and then try to calculate the average and get an average of 0. Like this. You know, int total is equal to -1 plus a 1 plus a -1. That's not going to work. Forget it. Just trust me on that. I'm not going to sweat for 10 minutes trying to concoct an example when it'll fit better when we're talking about loops. When calculating sums, it may be a good idea to store the results as a floating point number so that you can calculate an average from it and not worry about it rounding down. Yeah. So here's an example, right? Int total is equal to 3 plus 4. And then int average is equal to total divided by 2. That should work, right? But it's not going to work. It's going to say that the average of 3.4, well, what's 7/2 when they're both ints? It rounds down. So it's not 3.5, it's just 3. It would print that the average was 3. Well, I can fix that. I'm going to make this a double. Too bad, it's still going to print out 3. Why? Because this is still an integer divided by an integer. So it's going to round down no matter what we're storing it as. Right? It does all this math before it even finds out that it's supposed to copy it across the equal sign over here. It doesn't know whether this is a double or a long, or who knows what could be over here. It might not even be a variable at all. It may just be cout, right? So in order to get that to work, we should have made this variable a double. So when calculating sums, my recommendation is to always put the sum as a floating point type, even if it's just a series of ints. All right, time to wrap up. Time to see if I'm going to inflict more homework on y'all. Let me see what I did on Tuesday. That was the compound interest assignment. I think I'm comfortable just leaving that, not adding on to it. I'm slacking off though. Who wants more homework? I know that some of y'all are wishing you would, but you're just afraid to raise your hand because the other students will scowl at you. I'm kidding. All right, I think that we have covered some good stuff, but I don't see a reason to repeat. That what we have learned since then does not lend itself to doing more than what we've already done, because this is the kind of stuff that we've already talked about, and then now we're seeing it officially, right? My habit of showing you stuff before you've read about it. Okay, so let's make a Dropbox for what we did today. If you forgot to upload a CPP because I didn't specify that in the instructions for what to submit, please go ahead and do so. And if you honestly cannot find your code in order to do that, then just upload a note to that effect and I'll give you credit.